Hello class, today we are going to learn the applications of differentiations in rate of change. For solving rate of change problem, basically, we are going to follow these 4 simple steps. Step 1, you need to draw a picture of the physical situation. Step 2, write an equation that relates the quantities of interest. For example, to derive your equations, you may probably use a simple geometry fact like the relations between the areas, circle's areas and its radius, or the relations between the volume of a cone and its base, radius, and height. Maybe you may use a trigonometric function like the tangent function, or you may use the theorem Pythagoras, and finally, you may use a similar triangles to form the equations. Okay, step 3. Take the derivative with respect to t both sides of your equations. Remember, we need to apply the change rule here. In other words, we will do the implicit derivative. And step 4, you make a conclusion to solve for the asked quantity. Before we proceed to the examples, let us recall back some important formulas, especially for the volume and surface area for the shape of sphere, cone, and cylinder. Okay, let us proceed to the example 11. We have a spherical balloon is inflated at a rate of 100 centimeter cube per second. How fast is the radius changing when the diameter of the balloon is 50 centimeters? So, if the diameter is 50 centimeters, so that means that the radius is only 25. Okay, look at the diagram. Okay, we are given the rate of the volume. So that means that we have the dV dt equivalent to 100. Okay, how fast is the radius changing? So that means that I'm going to find my dr dt. Okay, when the radius is 25. So this is the radius of a sphere is r. So we denoted the radius of the sphere as the r. So after we have read the questions, okay, so we proceed to forming the equations. Okay, from the informations given, so I need to form the equations of the volume of sphere, that is 4 over 3 pi r cube, and the diameter to r is equivalent to 50. So that means that I have my r equal to 25 here. Okay, after that, I need to differentiate both sides based on the equations that I formed just now. So I double check first. I have my v, dv dt, and I have my r here. So I can start to differentiate implicitly both sides with respect to t. So I have my dv dt equivalent to 4 over 3 pi 3 r square dr dt. So after I simplify it, so I may have my dv dt equivalent to 4 pi r square dr dt. Okay, since I have my r equal to 25 and I have my dv dt equal to 100, so I simply substitute into the equations, differential equations. So I do the calculation and simplify it. I may have my dr dt is 0.013. So this means that the radius is changing at the rate of 0.013. So since the value is positive, that means that the radius is keep on increasing. We proceed to the example 12. A ladder 2.5 meters, so it's landing against the wall. Okay, the top of the ladder is sliding down at the wall with the rate of 0.6 meters per second. Okay, how fast is the bottom of the ladder moving along the ground at a point in the time when the bottom of the ladder is 1.2 from the wall? Okay, so for these cases, so for example, I denote the distance, okay, from the top to the bottom here as the value of y. The distance is y. So this means the distance from here to here is y, and the distance moving around from the distance from the ladder here to the wall is x. Okay, since the ladder is sliding down, so sliding down, this means that the rate of dy dt is negative 0.6. It means that the length of the y is keep on decreasing. So this means I put a value of negative here because they adalah decreasing. Okay, so I'm interested in finding what is the how fast the bottom of the ladder moving. So I'm going to find what is my dx dt, okay, when my x is 1.2. Okay, what is my dx dt when my x is 1.2? Okay, from the diagram, we may see that actually this is a right angle triangle. So this means that I may apply, okay, the formulas of the theorem Pythagoras. So this means that I may use my 2.5 square equivalent to my x square plus y square. So this is my theorem by Pythagoras. Okay, we proceed to the next step. So the equation is x squared plus y squared equal to 2.5 squared. So again, I differentiate with respect to t both sides by using the change rule. So I have my 2x dx dt plus the 2y dy dt. Differentiate of 2.5 squared is 0. Okay, I simply make a conclusions by substituting the value of x equal to 1.2 and the y as the 2.19. So I evaluate or I'm finding the y by using the theorem Pythagoras here. So I apply from these formulas. So please take note. Okay, to calculate or to evaluate my value of y. Okay, I simply put inside my differential equations. Okay, I have my differential equation of this. I just substitute the value of x and the y and the dy dt. Okay, to calculate and to get the rate of change of the dt as 1.0.95. So this means that the distance of the s is increasing. So that's why I have a positive radius rate of change here. So after I calculate my value, I need to rewrite the answers. So saya kena tulis balik. Okay, the radar move along the ground at the rate of 1.095 meter per second. So please make sure that during your PSPM, remember to answer back your the questions in the sentence form. In example 13, so before we proceed, I want you to make corrections on the questions. That is the water tank with a horizontal cone. Okay, it's not a cylinder. So please kindly make the corrections here. Okay, so based on the questions, so we have a water tank had a shape of horizontal cones with the radius of 1 meters. Okay, and the length of 2 meters here. Okay, if the water is being pumped into the tank at the rate of 1/6 meter cube per second, so this means that this is the volume, 1/6, the water volume. This is the water volume pumped into, so it's 1/6. Okay, find the rate of the water level is rising. Okay, when the water is 1/2 meter deep. Okay, I'm interested in finding what is my dH/dt. So the water level here is the H. Okay, so the here is the water level is keep on increasing because I pump the water inside into the tank. Okay, the H is increased and the R also increased. Okay, so I'm going to find my dH/dt when my H is 0.5. 1/2 ini maksudnya 0.5 lah. Okay, based on the informations given, okay, what equations that we can find? Firstly, we are talking about the volume of the water, and the volume of the water is following the shape of the cone. So that means that first of all, the formulas that I can form is the volume of the cone, okay, which is the 1/3 pi r square h. Okay, after that, I noticed that I have the parameter of V, R, and H. Okay, which is I have too much today. So I only interested on the V and the H only. So this means that I need to substitute my H in I need to substitute my R in the H term. Okay, what can I use is that I may use my formula of tangent. Okay, tangent is the opposite over adjacent. So I may have my tangent theta is R over H and is also equivalent to 1/2. So after I rearrange the equations based on this, okay, I may easily say that my R is equivalent to 0.5 H. So this means that I may substitute my R in the H term. So therefore, I may form my equation V in the term of H. Okay, I have my V in the term of H only. Why I do like that? Because I'm interested to find what is my dH dt, and I have the informations of dV dt. So this means that the R is useless here. So we are not going to use R here. So I denote my R in the term of H. After that, I start to differentiate. So I may have my dV dt, okay, equivalent to pi over 4 h squared dr dt. Okay, after that, I substitute my h equivalent to 0.5 into my differential equations. Okay, this one. Okay, I rearrange and I may have my dH dt as 0.84. 0.849. This means that the water level is rising or is increasing at the rate of 0.849 meter per minute. Okay, example 14, we have water is leaking from the bottoms of a conical tank with the radius of 1.5 meters and the height of 2 meters at the rate of 0.25 meter cube per minute. The tank was initially full. Okay, if the height of the water is 1 meters, can find the rates of change of the water level. Okay, and the radius of the water surface. So this means that here we have two questions that we need to find. One is the rate of change of the water level. So that is the dHdt. Another one is the drdt when the the height, is equivalent to 1 meters. Okay, so again, we are going to use the relations of the trigonometry tangents here. Tangent theta is equivalent to r over h and is also equivalent to 1.5 over 2. Okay, I'm going to get your 3 over 4 is that we have the 1.5 multiplied with the 3 over 2. Okay, this 1.5 is the 3 over 2, so you have the 3 over 4 here. Okay, since the water is leaking, that means that the volume is keep on decreasing. That's why we are going to have the negative 0.25 meter cube per minute because the water is leaking. Okay, I'm going to answer this question. So we proceed to the second. Going to form the equation. So I may have my equation in the term of V equal to 1 over 3 pi h square h. Okay, why? Because the water volume is in the shape of the cone. So I may use the formula for the volume of the cone 1 over 3 pi h square h and pi r square h. So I have my r equivalent to 3h over 4. Okay, where I get this? R over h equivalent to 3 over 4. So therefore my R is 3 over 4h. Okay, so I have my volume of 1 over 3 pi 3 over 4 square h because I substitute my R in term of h. So I simplify it. I may have my V in the term of h. So after that, I try to differentiate both sides with respect to t. So I have my left hand side as dv dt and my right hand side will be 3 over 16 pi 3h square dh dt. So I simplify it. So I get my 9 over 16 pi h square dh dt. Okay, after that I substitute my value of h and the value of dv dt respectively with the value of 1 and negative 0.25. Okay, I do the simple calculations. So I may have my h as the negative 0.15141 meters per minute. So that means that the water level is decreasing. So this means that the water level is decreasing with the rate of 0.141 meter per minute. Okay, to find the rate of the radius of the water surface, I may have my R equal to 3h over 4. I may use the relations of R equal to 3h over 4 here, much more easier. So I start to differentiate both sides. Okay, with respect to t, so I may have my dr dt and I have a 3 over 4 h is 1 dh dt, and I simply substitute my h equal to 1 and the dh dt as the negative 0.141, which is the value or the answer I get from part 1. So I do the simple calculations. So I have my radius is with the rate of negative 0.106. So this means that the radius of the water surface, so the radius of the water surface is decreasing with 0.106 meter per minute. Okay, for the example 15, the milk is being poured into a hemispherical bowl of the radius 4 case at the rate of 3 meters cube per second. So if the depth of the milk in the bowl is given of the volume by this. Okay, so at the instant the milk is 1.5 centimeter deep. That means at the height. Okay, so find the rates of the change of the h. So I'm going to find my dH dt is how much, and the rate of change of the radius of the milk surface. So that is the dr dt equal to how much? Okay, when your h is 1.5. Okay, and given that the dv dt is 3. So from the equations of volume given, we have the v equal to pi 4 h square minus the h cube over 3. So I do the differentiations respect to t both sides. I have the dv dt equivalent to pi 8x minus the h square dh dt. So I simply substitute my h equal to 1 over 5 and the dv dt equal to 3 into the differential equations, and then I get my dh dt is 0.098 centimeter per second. So to find my dr dt, so I have to use my theorem Pythagoras. So use the theorem Pythagoras here. So I have my r square equal to 16 minus the 4 minus h square. Okay, use the triangle here. So then after that, I differentiate both sides with respect to t. So I have my, for the r square, I have my 2r dr dt. And from here, I have my minus 2, 4 minus h power of 1, negative dh dt. Okay, so after that, I substitute my h equal to 1.5 and r equal to, so I simply substitute, okay, all the value of h and the r and the dh dt into the differential equations here, and then I can easily to get my dr dt. Okay, I have my dr dt equivalent to 0.078. So this means the rate of change of the radius of surface milk surface is 0.078 centimeter per second. Okay, that's all for today's lesson, rate of change. So please kindly answer your tutorial questions on the topic of rate of change.